let's have a look at what it says here. So when you are doing Euclidean geometry questions, grade 11s and grade 12s, the most important thing to do is read the information that you have been given first. Okay, sometimes everything that they give you is already on the diagram, but sometimes it isn't. So if you don't read the information, you might miss out on a few important bits and pieces. You also might find that sort of later on, after you've read the information and you've done a little bit of work, maybe on one or two questions, you might then get to another question where you get stuck. Go back and read the information at the top again, because maybe there's something else there that you missed the first time or you didn't think about the first time that you now need. All right, so step number one, always read the information carefully. Whatever they give you, if it's not on the diagram, put it on the diagram. Okay, so, oh, sorry, I'm just going to check the chat quickly. Oh, you're all saying hi to Kia. Oh, awesome. Okay, so in the diagram below, O is the center of the circle. So that's important for us. Let's just highlight that. Oh, hang on 1 second. Sorry. All right. I'm dozing here. Okay. Let's highlight that. So O is the center of the circle, and that's important to us because we know that there is a theorem that deals with the center of the circle. All right. Angle at center is twice angle at circumference. So that's a direct one, but there could be others. We've got two lines. So we've got OE and OB. Those would be radii. So that could be important to us as well. The other thing that they tell us here is that DEF is a tangent to the circle. So that's super important. When we see the words tangent, instead of me telling you, what do you think of when you see the word tangent? What theorems does that link to? When you see the word tangent, what do you start thinking about? Absolutely, tan chord theorem, 100%. What else have you guys said? Someone said tangent perpendicular to chord. Okay, so Lebogang, it's tangent perpendicular to radius. Okay, so tangent perpendicular to radius or to diameter. That's another important one, absolutely. That's it. Okay, or we could even think about tangents from the same point, but in this case, we don't have two tangents. We've just got one. Yeah, Msomi, I agree. Tangents from the same point is another one. Let's just put it here. So tangents from same point. We don't have another tangent, but if we did, that would obviously be, oh my gosh, my cat has just caught a bird and he's brought it inside the house. Okay. Sorry, guys. Oh, hopefully he gets it out. Okay. Let's go and have a look at the rest of the information. Okay, chord AB is drawn parallel to DEF. So the minute we see the word parallel, we need to go back to grade 8 and start thinking about all the grade 8 geometry reasons that are associated with parallel lines. So in other words, we need to start thinking about, let's put this on the side over here, corresponding angles would be one. Can anybody name another type of angle that is created when we have parallel lines that could be important to us? Alternate angles, absolutely, that's important. Alternate angles will be equal when lines are parallel. And of course, we could have co-interior angles, although that would sort of be less important to us, I suspect, at this stage. Okay, then they tell us some lines are drawn, that's fine. And the last bit of information they give us is that EOB is equal to 140. Okay, so calculate, giving reasons, the size of the following angles. So EAB is the first angle. So EAB, that means they want us to calculate the size of this angle over here. Oh, by the way, I hope all of you have got this information with you, because then at least you can draw on your diagrams and write on your diagrams as well. I think that's really important in geometry to be able to do that. Okay, so does anybody want to tell us what you think EAB would be equal to? Anyone got an answer already that they want to share? Lumelo says A is 70, angle it. That's it. There we go. Lovely. Okay. So Lumelo, that was perfect. What you said, you provided the reason as well. So in 7.2.1, let's pop it up here. We would say that EAB is equal to 70 degrees. Reason angle at center equals 2 times, sorry, just move that out of the way, times angle at circumference. Okay, fantastic. That's it. Well done, everybody. All right, so 1 mark for the answer for your statement, the other mark for your reason in this case. Okay, let's go and look at 7.2.2 now that we know that that's 70. AED. So AED is this angle over here. Here's AED. AED. How big is AED? Can anybody see that? Look at your own diagram as well, if it helps. Okay, so Cassandra, you say 126. Where do you get 126 from? Tandakile, Desedi, thank you. Siseko, all saying 70. Okay, Lumelo, right answer, wrong reason. That's it, Gugu. Okay, so Gugu, Mbali and Zanele, Lesedi, you are all absolutely 100% correct. Okay, so everybody else that's yes, pulling, perfect. Everybody else that's perhaps struggling to see this a little bit, I'm going to try and do this with my board. Okay, so we've got a parallel line over here. We've got that line, EA, over there, and then we've got this line over here. Can you see the Z now? Do you see the Z? Remember, alternate angles are the ones that make a Z shape. Okay, so quite right. AED is equal to 70. Reason alternate angles. And I know this is difficult to obviously put onto your cell phone, but you must name them parallel lines. Okay, otherwise they're not going to give you the mark. So we would say DE parallel to AB. Okay, good stuff, everybody. Well done. Okay, on to the next one. Let's see what angle they want us to do. BEF. Okay, so let's go and find BEF. We'll use a different color now. Let's use orange. BEF. BEF. Okay, so BEF is this one over here. Okay, now I just want to go back to something I saw in the chat. Plumelo, you said 70 tan chord theorem. Okay, tan chord theorem would work in that situation if you knew the size of, before we do this question, would work in the case of you knowing which angle. If you wanted to say E was 70, which angle would you need to know was 70 to use tan chord theorem? That's it. Good. Well done. Well done. Well done. Okay, so you're quite right. If you knew that angle B was 70, you could say that AED was 70 because of tan chord theorem. Okay, but we don't actually know the size of the angle at B just yet. Okay, now, Lumelo, if you have a look at where BEF is and angle A at the circle, now we can say that BEF will be equal to that's it. Well done. So it will be equal to 70 and your reason. Tan chord theorem. That's it. Well done. Okay, so I'm just going to point that out just in case it's not obvious to everybody. All right, so statement reason, as geometry always gets marked. Okay, so what we are looking at here specifically, grade 11s and grade 12s, is, and I'm going to draw this in orange, okay, is we have got the angle at E. The orange line that I'm drawing now is the tangent. Line EB, which I'm putting an orange line over now, is the chord. Okay, so that's why angle BEF is the angle between the tangent and the chord. So essentially what you are doing is you are putting your fingers at E and B, and then you are following the lines to the circle. Okay, so we're following these lines to the circle now, going over those yellow parallel lines. Okay, and A is the angle in the alternate segment, so the other segment. Okay, so this line EB, it's a chord. It cuts the circle into 2 segments. All right, and angle A is in the alternate segment. Okay, so that's why we would say tan chord theorem in this case. All right, how's everybody so far? We good? Is this making sense? Any questions? Are you all right? Gugu, you happy? Lesedi, fine. Puling's okay. Grade 11s, are you okay as well? Okay, so lots of thumbs ups coming through. Okay, nice. Okay, excellent. And then let's do the last one. Okay, so now they want from us, yes, they want from us A, E, O. Let's go and find it. A, E, O. All right, now I think maybe what I should do here is just get rid of all of this. We know that this is 70. We know that this is 70. We know that this is 70. So we'll just put those ones in. I mean, for argument's sake, we actually also know that that one would be 70 as well because of tan chord theorem as well. But I mean, they didn't ask us for that particularly. But what they want from us is this little angle in here, AEO, AEO. It would be this little guy over there. And I think some of you are already putting the answer into the chat. Okay, Hlumela, I'm going to read what you've said now. Just give me 1 second. So, Lihlu, you are saying AEO is 20. Very nice, Lihlu. Lovely. Cassandra, you're saying 20 because of some of angles in a triangle. Okay, but then Cassandra, if you're working in, which triangle are you working in, Cassandra? It must be AEB, right? You would also need to know the size of this little angle over there, Cassandra. Yeah, AEB. So you see where I put the little pink dot, Cassandra? Because this tiny little angle over here, let me color it in green. This one here where the pink dot is, you would need to know the size of this angle as well, because it's also part of angle E that is inside triangle EAB. Okay. Yes, so it would be 20, that's quite right. But if you were going to do that, you have to explain where it comes from, all right? So in other words, you can go the long way round if you want. But if you go the long way round to explain anything, you have to then say where it comes from. So what you'd have to do, Cassandra, just before we move on, the others they've just done it a little bit shorter than you. You would have to explain, first of all, OE equals OB radii. Therefore, angle OEB equals angle OB, OEB equals OBE, angles opposite equal sides. Therefore, that little green bit is 20 degrees. All right, and then you would have to do angle sum and triangle. Whereas this is only worth 2 marks. So what we want to try and do, Cassandra, is get to the answer in the fewest steps possible, because all of that takes up our time when we write all of that, it's going to take our time away from being able to look at the slightly more difficult questions. Okay, nothing wrong with it. Nothing wrong with it at all. It's just time consuming. Okay, now I just want to go back. Sorry, Lumelo's busy writing to me again. I just need to read what they've said. Ma'am, since we know that yes, 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 absolutely. That's exactly what I was saying to Cassandra. Quite right, Lumelo. You saw that already. Yes, perfect, perfect, perfect. Okay, so try and do it in the shortest way possible, just to save you a bit of time. If you guys go back and have a look, Lichlu said AEO equals 20 tan perpendicular to radius, and that would in fact be the quickest and easiest way to answer this question. Yes, Lebogang, I see you've got a hand up. Do you want to ask a question? You're welcome to unmute. And Lesedi, you've got a hand up as well. Lebogang, did your hand go away? You put your hand down. Lesedi, you're welcome to unmute and ask. Oh, please unmute you. I don't think I can. Kia, I don't think we can unmute them. They have to unmute themselves, don't they?
I can unmute them. I unmuted Lesedi. So I don't know if they still have a question.
Yeah, I think
but I can
Lebogang,
quickly move to Lebogang.
Please.
Just look for a message on your screen that's going to ask you to unmute and click confirm. There we go.
Thank you, ma'am.
There we go. Hello.
Hello. Hi, ma'am.
How are you?
Good to you, ma'am. Ma'am, I
Fine,
wanted
thank
to
you.
ask, they told us at school that in finals, our question paper doesn't get handed in with our answer sheet. So, ma'am, do we do the writing on our answer sheet?
So Lebogang, what they have for paper 2 is a special answer book. Okay, and you'll see for the grade 11s, it should be the same case as well. All right, if you're writing an external paper, or even if you're writing an internal paper at the end of the year, your school, or if it's a department paper, the department will send you an answer book, and that answer book has all the diagrams drawn in it as well. So what you would be able to do is work on your question paper as well as in the answer book as well. But yes, when you leave the exam at the end, you take your exam script with you. Okay. All right. Lesedi, what was your question?
Lesedi, just look for a message that's going to ask you to unmute. There we go.
Okay, thank you. Hi, ma'am.
Hi, Lesedi.
Ma'am, may you please show the tan that's perpendicular to the radius for the reason of 7.2.4?
Yes, absolutely. We haven't finished that question. No problem. So I'm going to point it out to you. All right. So the line that Lichlu was looking at was this line over here in blue. That is your radius. Okay. Your tangent, I'll put in pink. There's the tangent. The tangent is DF. DEF is your tangent. Oh, that's very badly drawn by me. Oh, my computer didn't like that. Okay, I'm not surprised because it's a horrible line. Okay, so there is your 90-degree corner over there. Can you see that? All right.
He said yes.
So cool. All right. So in terms of setting this out, we could say OED equals 90, radius perpendicular to tangent. Therefore, our angle that we want, AEO equals 20 degrees. Okay, so for this, it would be the answer together with your reason. Okay, so sorry, it would be answer mark there, and here statement reason in 1. Okay. All right. Well, I think that was a nice way for us to get into this and start having a look at some of the things that are going to come up later on and some of the easier questions that we can do. Let's jump into the next thing. This diagram is a little bit more complicated. There are a lot more lines. And they've told us here that ABCD is a quadrilateral. Now, one of the worst things that you can do in geometry is make assumptions. Okay, just because they told us that it was a quadrilateral does not mean that it's a parallelogram. We can see that it's got one pair of opposite sides that are parallel, but we don't know anything about AD and BC. So we cannot go making assumptions about sizes of angles and lengths of opposite sides, etc., etc. All we know is that it's a quadrilateral at this point. The other thing that they've told us is that it has diagonal side AC equal to side BC. Now this is where reading the information is so important. So they've told us that diagonal side AC is equal to side BC. Now that is not on the diagram. So here, side AC is this one, and it is equal to BC. That's this one. Okay, so if they tell you that two lines in a triangle are equal to each other, what does that mean for us? The minute we see that, what information do we automatically know straight away? Okay, there we go. Angles opposite equal sides. Absolutely. So in this case over here, it means that that angle over there at B and this angle over here at A have to be equal to one another. Okay, because they're angles opposite equal sides. Okay, well done. Perfect. Let's go on and see what else they tell us. BE is perpendicular to AC. All right, and that has been put onto the diagram. Okay, we've got that right angle in there. Okay, the other thing that's not on the diagram in this case is the last piece of information here, where they tell us let ECD be X. Let ECD be X. All right, so let's go and put our X on the diagram. ECD is this angle over here. Okay, and that's the one they've said, let it be X. Now, another very typical sort of question. In 8.1, they want us to name with reasons 3 other angles in the figure that are also equal to X. Okay, have a look at the diagram. Lebogang, I'm just going to read what you said, man. We need to know. Lebogang, can you just be specific about what that is? Which corollary are you talking about? Angles are equal. Cassandra says BAC. There we go, Cassandra, quite right. Yes, Lumelo, you and Cassandra have got that one. Perfect. Okay, so the two of you have spotted the parallel lines. I don't know if anybody else can see this, right? But both Cassandra and Lumelo are saying, if you have a look here, and I'm going to go over the yellow line now, I'll try and just go next to it. And then coming up here, we've got a Z shape. So we've got an alternate angle sitting over there. Good, well done. So that means that BAC equals X because of alternate angles. And again, we have to name the parallel lines. BA parallel to CD. Perfect. Now they want 3 other angles that are equal to X. So we've got 1. Let's see what else is equal to X. So I see a couple of people. Lumelo says ABC, angles opposite equal sides. Cassandra, you're trying to say the same thing. Lebogang, angles subtended by the same arc. Yes, Lebogang, you would. Sorry, I'm saying answering 2 different things at the same time. So what Lebogang is asking me in a direct chat is, would you need to know angles subtended by the same arc? Yes. Or sometimes they call it equal chords subtend equal angles. It's also referred to as that. So yes, you would need to know that, Lebogang. Okay, so going back here, we've already established that this angle at B would also be x because of angles opposite equal sides. So quite right, we can say ABC equals x because of angles opposite equal sides. Okay, and they're really fussy about this reason, grade 11s and grade 12s. If you muddle up the order of the words here, you're not going to get it right. So make sure that you've learned this one very, very carefully. Okay, angles opposite equal sides. And you can't say sides opposite equal angles because that means something else. It's actually the reverse of this or the opposite of this. You can't say opposite angles equal sides. They will mark you down. All right, so they're quite fussy. So also, Lumelo has also just direct messaged me. No, you're actually not allowed to use isosceles triangle as a reason. Okay, so that we haven't done that in a number of years now. I have heard rumors that they're going to start accepting it again, but it's just a rumor. Okay, so please, 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 everybody use angles opposite equal sides. In fact, when I teach grade 8s, I tell them that the word isosceles is a swear word. I mean, it isn't, but they're not allowed to say the word isosceles. Okay, just to try and help them to remember not to say it. Okay, so yes, please use angles opposite equal sides. Okay, so you've been two sides in a triangle, the angles opposite those two sides. All right, so we've got some angles. Now we want the third angle here. Remember, this is the one that we were given. So we're looking for one more. Where is it? Can anybody spot it anywhere? Okay, so a couple of suggestions here. Cassandra says APF. All right, so let's just have a look at your suggestions here. APF. So Cassandra is suggesting that it could be that one. Let's see. D is what Lebogang is saying. So I'll just put that over there. AFC. Ooh, we're getting closer. Let's just see who said that. Lumelo. AFC. So that would be that angle over there. All right, Kutlwano, you were saying, can I say angle D equals X because of corresponding angles? DPF, says Lesedi, DPF. Okay, so that would be this angle. That would be this angle over here would be DP, would be DPF. Okay, now let's just hang on a second and let's just talk about some of the suggestions that have come through here. All right. Let's just eliminate the ones that it can't be. All right. It can't be DPF, unfortunately, because DPF, we do not know that line PF is parallel to line AB. We know that line AB is parallel to line CD, but we don't know that line FP is parallel to either of those. So that, unfortunately, is not going to work in this situation. So let's eliminate this one. Okay. Now, someone else is saying angle D. Now, if this was a parallelogram, then it would be angle D. Absolutely. Okay, but the problem is we do not know that this is a parallelogram. We know it's a quadrilateral and we know we've got one pair of opposite sides that are parallel, but we don't know if we could work out that AB was equal to CD first and establish that ABCD was a parallelogram, then yes, it would be true. Okay, but we don't actually know that. So I don't think that D is going to be a good suggestion for now. So let's eliminate that one. Let's just see what else you guys are saying in the chat. It's D because of co-interior angles. Okay, but co-interior angles are supplementary. They add up to 180. They're not necessarily equal to each other. Okay, what else was suggested here? Okay, so Okay, so you can't just exactly. Okay, you cannot assume that it is a parallelogram. Okay, and this is exactly it, Lebogang. We get a little bit of information, and if we make an assumption, then we're going to get the wrong answers. Okay, all right. So PFC says Mbali and Zanele because of corresponding angles. So let me rub out this over here. PFC because of corresponding angles. Now, why does that not work either? Mbali and Zanele, thank you for your suggestion, but why is that not going to work either in this case? Exactly. PF is not, we don't know exactly, don't make any assumptions. It could very well be parallel, but we haven't been given it, we haven't proved it, we can't use it. Okay, so unfortunately, it's not that either. Okay, so now we're kind of out of options. We know it's not this one. We know it's not this one. We know it's not this one. What else in this diagram do we have that we can use? Okay, so Cassandra says with APF opposite APF. No. No, I don't think I would do that either. Okay, so when we get stuck like this, we've got to go back and go and look at it again and say to ourselves, okay, is there something here that we've missed, that we haven't seen, we haven't considered yet? What's missing? Lebogang is at angle E. Okay, why would it be? Are you talking about which angle at E? Okay, the other thing here, you can write your answer, some of your answers in terms of X, that's not a problem. Okay, but we do, that's another problem. Can you see, look at the next question. It says ABFE is a cyclic quad. If it's a cyclic quad, why is one line perpendicular to another? So we don't know that the quad is cyclic yet. Okay, we haven't been able to do that. So what other angles do we have in this situation that we could possibly use? Okay, we don't know that it's a cyclic quad. So we've got our alternate angle. We've got our angles opposite equal sides. We don't have that line parallel. That angle over there. We don't have angles in the same segment. I'm just having a look at, we know this angle here and that angle there. So this one would be 180 minus 2x. I wonder what they wanted here. C and F. Angles in the same segment. So if you're working with angles in the same segment, then you've got to know that the quad is cyclic. I can't see anything else that x could equal in this diagram, actually. They've said 3 here. 3 other angles. I don't know about H. H just seems to be where lines are crossing over one another. They didn't ask us to prove anything else either, did they? Klumelo, yes, exterior angle of triangle is a very, what's it called? We often don't think about it, you know, and it's a very sort of small, insignificant reason. What could we use with exterior angle of triangle? Let's just have a look at what else we've got here. Ah, you know what? You know what? Ha 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 ha. This is so sneaky, guys. This is so sneaky. Check this out. I've just figured it out. Although I haven't just figured, I should know this. Look at this. What is this thing that I've just colored in pink here? No. No, sorry, no, exactly. It's a cyclic quad. And what do we know about the exterior angle of a cyclic quad? I think someone actually said this angle earlier, but we didn't talk about it. The exterior angle of a cyclic quad is equal to the opposite interior angle. Okay, so that angle there at P, APE, I know somebody mentioned it earlier, I didn't think we had the right reason, but APE would also be equal to X. Can the rest of you see that? Okay, because angle C over here is X, that angle at P that I've labeled X would be the exterior angle. Yeah, there you go. Okay, but we just didn't have the right reason, Cassandra. Okay, but wrong reasons. Exactly. Well done. Okay, so that was super sneaky, wasn't it? Okay, so APE is also equal to X. All right, because of exterior angle of cyclic quad. But you know what? I'm so glad that we've had an opportunity here to look at all the other angles as well and work through the ones that are not applicable. Because with each situation like that, it's important for you to see how making an assumption about either PF being parallel to AB and DC, which it isn't, or you know, any of the other things that have come up, how that's not going to be correct. Okay. All right. Now, Lumelo asks, how do we know that the quad is cyclic if we didn't prove it? Can anybody answer Lumelo? Why did I not need to prove that PDCE was cyclic first? Why am I allowed to do this? Okay, Cassandra, you're close. It's not about the sides. Okay, all the angles are touching the circle. Well done. Mbasa, that's what you said. Lebogang, all the points touch the circumference. Saw me saying the same thing. Is it because all points are on the circle? It is. Okay, so Hlumelo, you do not need to prove that a quad is cyclic when its 4 points are on the circle, because that's what makes it cyclic. Okay, when they're asking you to prove that a quad is cyclic, they're asking you to prove that it's possible to draw a circle through all 4 vertices that would be on the circumference. Okay, so that's why it's not necessary to prove it. Okay, and they didn't tell us this in the beginning, all right? They didn't say that PDCE is a cyclic quad because they wanted to make the question that little bit more difficult. Okay, All right, so there we have found our third angle. All right, tucked away there at the exterior angle of the cyclic quad. Okay, cool. So the three angles we found here, it's only worth 4 marks. So what I would say in a situation like this, grade 11s and matrics, is that the first and the second X that we found, you would get 1 mark, statement, reason, statement, reason. And then because this last one was a little bit more obscure, it would be statement, reason, like so. Okay, all right. Let's go on to the next question. Now they say to us, if ABFE is cyclic. Okay, so let's just draw, let me get a different color. All right, so if ABFE is cyclic, so just highlighting that for ourselves to make it stick out here. Why is AF perpendicular to BC? Why is AF perpendicular to BC? So in other words, why is there a 90-degree corner over here? If this quad is cyclic, why is that 90? So again, have a look at your own diagrams. Can anybody see this? If ABFE is a cyclic quad, why is AF perpendicular to BC? Might be a little bit difficult on my diagram given I've drawn all over the place here. Can anybody see that? I'm just going to try and get rid of some of these lines here. And draw the cyclic quad in again. No. So again, Lumelo, no assuming. Okay, we do not know that H is the center, and there are no theorems about the center of a cyclic quad either. It's only the center of a circle. Okay, so now, does everybody, let's just see if there are any more suggestions coming through. Does everybody have this in front of them? Do you have it as a hard copy in front of you whilst you're looking at the screen? So Barley and Zanella saying yes. H, B, F, H. No, Cassandra, angles at circumference are not equal. That's not the right reason. What you've said about the angle is correct. Okay, so now what I want you guys to do, everybody who's got this as a diagram in front of you, this is what I want you to do. Put your fingers at A and B on your diagram. Put your fingers at A and B, and then move along line AE and BE. All right, you come up to E, okay, which is a 90-degree corner. Go back down to A and B, and now follow line A through to F and line B to F. What am I trying to show you? So your fingers at A and B, go to E, go back to A and B, now go to F. What am I trying to show you? No, it's not the diagonals that bisect each other. There we go. Flumelo's got it. Good. Okay, so everybody else, it's angles in the same segment. Yes, essentially, Lichlu. Essentially, okay. AB is the chord subtending both of those angles, and since the quad is cyclic, they would be angles in the same segment. Exactly. Okay, so again, everybody, fingers at A and B, go to E, go back to A and B, go to F. All right, so what we could say here in 8.2 is that AFE equals AEB equals 90 angles in the same segment. Okay, so answer, statement, and reason over there. Okay, are there any questions before we move on? No, all good. Yes, of course, Lebogang. What do you want to ask? You're welcome to unmute and speak, Lebogang.
Ma'am, can you please explain the angles in the same segment, because I get confused with that one a lot.
Okay, all right. So angles in the same segment is the bow tie. It's the bow tie inside a circle, but the 4 points have to be on the circumference, or the quad has to be cyclic, which is essentially the same thing. Okay, so angles in the same segment, you are looking for, I'm just trying to see. Okay, so if you have a look at this diagram over here, all right, if you look at PFSO, if we knew for sure that PFSO was a cyclic quad, angles in the same segment is the bow tie. Okay, so it's these lines that cross over one another here, your bow tie like that. That's so angles in the same segment would be those ones there, or it would be these ones over here. Okay, so when we first start learning about this, let me try and draw something here on the side for you. Just scooch over a little bit. It looks like this. So if this is your circle, okay, sorry, terrible circle, and you have a bow tie on the inside. Okay, there's your bow tie. So angles in the same segment. This one here with a black circle and that one there with a black circle, those are equal, okay, because they are subtended by the same arc. Okay, so if I called this arc AB, I could say AB subtends angle C at the circle, and it also subtends angle D at the circle. Whether I join A and B with a straight line and make a chord there or not is irrelevant. Okay, so if it's the same piece of arc or the same chord that subtends an angle at the circumference, those angles will be equal to one another. Okay, and then for the same reasons, we could say that this angle over here at A and that one over there at B would also be equal to each other because of angles in the same segment. So inside here, what you've got in this green cyclic quad is you've got those diagonals from vertex to vertex. Okay, so that's why this angle over here, E, and this angle over here, sorry, it doesn't include that little bit. Okay, let's just get rid of that green line. It doesn't include that little bit. It's just this angle over here. Okay, they would be angles in the same segment. Okay, Lebogang, I hope that's a little bit easier for you to see now. No. So if the quad is cyclic and you've got a bow tie inside it, then you can use angles in the same segment. Okay, Lebogang. All right, cool beans. Okay, everybody, let's get into something that is definitely going to challenge us a little bit more. All right, now, whether you are in grade 11 or grade 12, these are very common questions that come up, and this is certainly where things start to become a little bit more difficult. All right, they are always grade 11, grade 12 going to make you prove that a quad is cyclic. And in grade 12, they will definitely also ask you another question. So proving a line is a diameter or proving a line is a tangent, something like that. So in this case here, let's start by reading the information. I think what I'm going to do is make this even bigger so that it's really easy for us to see everything that's going on. In the diagram, O is the center of the circle. So again, when we read O is the center of the circle, they must be telling us that for a reason. It could be line at center is, sorry, angle at center is twice angle at circumference. It could be because we've got equal radii. Not a little difficult, extremely a lot difficult. Fair enough, Teddy. Fair enough. Okay, so here we need to be aware of radii. We need to be aware of angle at center equals 2 times angle at circumference. We could also potentially have angle in a semicircle. If they tell us that we've got a diameter, let's just see what else they say. Okay, diameter RS, yes. Diameter RS is produced to Q such that PQ is a tangent to the circle at P. All right, so loads of information in that second sentence. First of all, they've told us that RS is a diameter. When they tell us a line is a diameter, what does that mean immediately for us, grade 11s and grade 12s? What is the word diameter straight away? What do we think? "90 degrees, where, Oratile?" That's it, Teddy. Angle in a semicircle. That's it. Angle in a semicircle. Okay, because the diameter cuts the circle in half, doesn't it? Right, so this angle over here. Good, well done, Oratile, quite right. The rest of you all saying the same thing. Puleng, Lesejo, Mbali and Zanele. Good. Okay, so P is 90 degrees. Excellent. And now they also tell us that PQ is a tangent. So we've seen this word before. And we've discussed what could happen when we see the word tangent. So here we're starting to think like we did earlier about tan-chord theorem. We're starting to think about radius perpendicular to tangent. We could also start thinking about tangents from the same point if we had more than one tangent. Okay, but we definitely do have an angle between a tangent and a chord. Incidentally, if angle FPS, this angle over here, if it's the angle between the tangent and the chord, which angle would it be equal to? Which angle would it be equal to? So the angle that I've colored in green is the angle between the tangent and the chord. That's it. Well done, Cassandra, Gugu, and Lebogang. Quite right. It would be equal to R. Okay, because of tan-chord theorem. Okay, so your chord is PS. So the angle QPS is between the tangent PQ and the chord PS, and line PS subtends are at the circle. Good. So that would be tan-chord theorem. Excellent. So when you read all of this information, what you are doing is that you're gathering clues that you're going to use later on. All right, you read all of this and then you start putting things together, things that could potentially be equal or are already equal to 90, etc., etc. Let's have a look at the rest of the information. It says F is a point on PQ such that OF bisects PS. Now that's also a loaded statement, isn't it? F is a point on PQ such that OF bisects PS. All right, so they've put that onto the diagram. What does the word bisect mean for us? Has a very specific meaning. Exactly, cut in half. Cut in half. So to bisect it means it's been cut in half. All right, so if OF bisects PS, it means that PS is cut in half. So in other words, PW equals WS, or W is the midpoint of PS. That's what they're telling us. Okay, now something else I just want to point out at this stage, and this is something that maybe the grade 12s could have forgotten about, but the grade 11s might be sort of slightly more aware of. If you have a center and a line from the center that bisects the chord, what happens then? Can anybody remember that chord theorem? What are they trying to get us to think about here? That's it, Lumelo. Line from center to midpoint of chord. Beautiful, beautiful, beautiful. Line from center to midpoint of chord. Okay, well done, Lumelo. That's lovely. Okay, so in other words, there also has to be a 90-degree corner over there. Okay, so here, one of the chord theorems coming through as well. Okay, then they tell us PR and RS are drawn. Okay, let's go and have a look at what they want us to prove. The first thing is that RP is parallel to OF. RP parallel to OF. Okay. Matrix, we're not thinking about the converse of the proportionality intercept theorem. We've got to think further back than that. Grade 11s, you don't know what I'm talking about now, but you will next year. How do we prove lines are parallel? How do we prove that lines are parallel? Okay, so Lumelo, you're saying okay. All right, Lumelo. Your reason is not right, but what you've said to me is correct. Yes, good, well done. Let's see what everybody else is saying. Lumelo, you're onto something. Okay, well done. Lovely geometry. Exactly. So we don't know that the gradient is equal because we've got no way of calculating the gradient of these lines. I don't want to say it just yet. I just want you guys to have an opportunity to look at what's in front of you. Oh, there we go, Gugu. Well done. Okay. Nice. Okay, so everybody, you can see what Gugu has put on. She says P and W are both equal to 90. Absolutely. Okay, so can you see how when you read the information that comes at the beginning of the diagram, and you interpret that information and you put it onto the diagram, that it can actually help you to answer the first question? Okay, so that's why I was saying to you at the beginning of the session again, read the information that the diagram comes with very, very carefully. Don't just rush into the questions, because there you go. Everything we needed to answer this question was actually already staring us in the face. Okay, all we need to do now is put it down on paper correctly. Okay, very nicely done. Well done. And I must just say that Lumelo actually said that via DM message to me, and I'm glad they did that and didn't spoil it for anybody else. Okay, so what Gugu is getting at is this. Remember in the beginning, we concluded that the angle at P, so RPS, has to be equal to 90 because of angle in a semicircle. Then I think it was Flumelo as well, correct me if I'm wrong, we agree that the angle OWS has to be equal to 90, okay, because of line from center to midpoint of chord. So that means that angle RPS and angle OWS are equal to each other because they're both equal to 90, and the lines will be parallel because corresponding angles are equal. Okay, so in 9.1, let's get all of this down. So in 9.1, well, you see, Cassandra, if you want to answer these questions, then yes, you would need to do that. Okay. All right. So RPS equals 90, angle in a semicircle, angle OWS equals 90, line from center to midpoint of chord. Now, very important, we must conclude RPS equals OWS. Therefore, RP parallel to OF because corresponding angles are equal. Okay, so 3 marks here. Statement, reason, and then this statement over here that I'm underlining in green together with your reason over there would be your last statement, reason mark. Okay, how do you feel? How do the rest of you feel? Is this making sense? Is this very difficult? Where are you at? Yes, Teddy, go for it.
It does make sense, but personally, when I usually come to these questions, like I didn't know at all that if angles that lie in the same angle, like on the same angles that how can I say now, corresponding, like the reason I didn't know, like just because of now angle P and angle W are both 90, which means they are now parallel to each other.
Okay. All right. So
Like,
you didn't know that you could use corresponding angles are equal to prove that lines were parallel?
yes, basically.
Okay. All right. So you you can also use alternate angles are equal to prove that lines are parallel. And you could even use co-interior angles are supplementary to prove that lines are parallel. Okay. Yeah. So these are definitely your higher order sort of very, very difficult questions. Remember, there's also going to be enough other level 1 and level 2 questions for you to be able to get all your marks if something like this intimidates you too much. I just think it would be nice if we can just do one example like this, just so that you're able to actually see what else is possible. Okay. All right. So Puleng, when you say you want me to explain it again, what is it exactly that you don't understand? And maybe Kia can help you on the side. Kia, maybe you can just reach out to Puleng and just see what they're struggling with. Lesedi, do you want to ask something? You're welcome.
Ma'am,
Hi, Lesedi.
ma'am, may you please explain the reason of line from center to midpoint?
Yes, with pleasure. Okay, that is definitely something that's worth us discussing. Okay, so just quickly here on the side before we prove that POSF is a cyclic quad. You would have done chord theorems, probably the first theorems that your teacher would have taught you in Euclidean geometry. Okay, so what we have is the center of the circle, and we have a chord. And if that line that comes from the center of the circle, if it bisects the chord, so let's call that O, let's call that A, let's call that M, let's call that B, it works like this. If OM bisects AB, so OM cuts AB in half, and OM is a line from the center of the circle. Okay, so here and O is the center of the circle. Then angle OMA, or you could write it as OMB, or OMB equals 90. Reason? Line from center, center to midpoint of chord. Okay, that's what we were working with now. Okay. The converse of this, although we don't refer to it as a converse because it's something we actually work with all the time, is the following. Let's draw another circle. Terrible circles here, but anyway, never mind. Again, O is the center of the circle. Here I have a chord. And now I'm given a 90-degree corner. So say O, A, M, B. Now, if, okay, OM is perpendicular to AB, or they could say that OMA equals 90, or they could say that OMB equals 90. So they could tell you those two lines are perpendicular in 3 different ways, okay? And O is the center of the circle, and O is the center of the circle. Then it is true that AM equals MB, line from center perpendicular to chord. Okay, so Lesedi, those are the 2 chord theorems that you need to know for this section. Okay, they're opposites of each other. Okay, so the one on the left, you're given the midpoint. You conclude that the lines are perpendicular. All right, so line from center to midpoint of chord when you're given the midpoint. Okay, when you're given that OM is perpendicular to AB, and you are explaining why AM equals MB, you've been given the right angle, so you say line from center perpendicular to chord. Okay. Yeah, so Lebogang, I can tell you now, it's the proof of the proportionality intercept theorem and the similarity theorem. Okay, so I'll just write that to you. So it's the proportionality intercept theorem and similarity theorem. But bear in mind, matrix, they can ask you to prove one of the grade 11 theorems as well. Okay, so they could ask you the proof of angle at center is twice the angle at circumference, or the proof of the tan chord theorem, or they could ask you to prove that the opposite angles of a cyclic chord are supplementary. All right, so grade 11s, you would need to know those as well. Okay, so now that we've attempted this difficult question, let's go and see if we can prove that the quad is cyclic. Okay, because this is something all of you are going to have to, or all of you would be expected to be able to do. All right, so let's just do it slowly and step by step. Okay. Bearing in mind now that once we have proved that something is true, we are allowed to use it. Okay, so we now know that those lines are parallel to each other. So we've proved it, we can use it, We may need it to answer the next question. We'll just have to wait and see what happens. Okay, so now they want us to prove that POSF is a cyclic quad. So let's highlight POSF. I'll get rid of all of that. Okay, we know these lines are parallel to each other. So POSF is that over there. Okay, before we can prove that a quad is cyclic, or should we say before we can attempt to prove that the quad is cyclic, can anybody tell me how that's done? What reasons do we use to prove that quads are cyclic? Okay, so the opposite angles add up to 180, correct? Okay. Opposite angles are supplementary, quite right. That's one of them. So let's just make a little heading over here. So proving a quad cyclic. So you guys are saying the one way we could do it is to prove the opposite angles add up to 180. Okay, cool. Exterior angle. Okay, so we can prove an exterior angle equal to an opposite interior angle is another way we can do it. And I think you guys have said the last one as well. Absolutely. Okay, you can prove angles in the same segment are equal. Good. Okay, so you guys do know how to do this. Okay, you're telling me this. Brilliant. So we've got those three options. Either we have to prove that the opposite angles add up to 180, or we have to prove there's an exterior angle which would be equal to an opposite interior angle, or we could prove angles in the same segment. We could only prove angles in the same segment if we have a bow tie inside, okay, which we do in this case. All right, we do have a bow tie inside, so that could be an option. All right, if we were to work with that first of all, is there anything that we already know that we could work with in this case? Are there any bits and pieces that are equal? So I'll tell you what, if we call this one X over here, we know that that's X. Is there anything else that could be equal to X? Now that we know that those lines are parallel. Cassandra's saying OPF equals OSF. Why? Why does that equal? There we go, Teddy, corresponding angles. So what angle corresponds with R? What angle corresponds with R, everybody? No. There we go, POS. Not POS, FOS. Oh, exactly, FOS. This guy over here. All right, it's now corresponding angle because we proved that RP and OF were parallel. Okay, Gugu, it's just an easier way of working. All right, so instead of saying this equals this, or what I could do is I could draw on the diagram. So I could draw little green circles and say, well, this is equal, this is equal, this is equal. It's just a way of working out which angles are equal and then saying, okay, what have I got that's equal that I could use in this case? Okay. All right. So believe it or not, you guys have got that this quad is cyclic already. You've cracked it. You've got the answer right in front of you. The house. Okay. Remember, we spoke about how we could prove that a quad was cyclic. Yes, we said opposite angles add up to 180, or prove an exterior angle is equal to an opposite interior angle, or prove that the angles in the same segment are equal. Hint, hint, hint. Look at the diagram. What's Hulumelo saying? WPF is equal to FOS. So the quad is cyclic since angles in the same segment are equal. Hulumelo, you are a genius. Well done. Okay, can you see everybody else? Right? We said in the beginning, okay, that because of tan chord theorem, this angle over here and this angle over here are equal to each other. Now, because we've proved these lines are parallel, like Teddy pointed out to us, we've got this angle over here that is corresponding with R, so they are equal. So now that means that the green angles inside this pink cyclic quad are equal. That's angles in the same segment. Look, line FS subtends P, okay, and it subtends O. All right, so that's why the quad would be cyclic. Can you see that? Okay, I know Lumelo can see it. What about the rest of you? Can you see that? You can. Oh, good. Okay. I'll say it one more time. Okay. So the green angle at P is equal to the green angle at R because of tan chord theorem. The angle at R now equals this angle over here, this green angle at O, because the lines are parallel. Okay, these are corresponding angles. Okay, sorry, I don't know why it keeps taking that away. It's very irritating. Okay, so the quad is cyclic because angles in the same segment are equal to each other. Okay, line FS subtends O, back to FS. FS subtends P, because those angles are equal to each other. The quad is cyclic. Okay, lovely. Well done. Okay, very nice. Now let's put that down. Okay, so we're going to say FPS equals R tan chord theorem. Then we're going to say that angle R equals angle FOS because of corresponding angles. RP parallel to OF. Therefore, angle FPS equals angle FOS. Therefore, POSF is cyclic, and I use converse angles in the same segment. Okay, so there's a few thumbs up that is coming through on this question. I'm so pleased for you guys. I want you to be able to see this because it would be great if you could also answer these questions and access those marks in your exams and in your tests that are coming up. Okay, they will always ask you to prove that a quad is cyclic. So we know guaranteed this is one of the questions that we're going to get. Okay, so Teddy, we're allowed to use the word converse because we're using the word cyclic. If I can't use the word cyclic if I don't use the word converse in this situation. What it means is that I'm proving the reverse. So in other words, because angles in the same segment are equal, the quad is cyclic. So I say converse angles in the same segment. Okay, because I'm not given the quad is cyclic, I'm proving it's cyclic. Okay, so converse means I'm working backwards or doing the opposite. Oh, I'm so pleased. You know what's funny? This lesson made me understand the tan chord theorem. I'm so glad. That's what I want for all of you, is to be able to walk away from this lesson and say, well, I know a bit more than I did before. I feel more confident. I think I can try these questions. I'm going to go and practice. That's wonderful. Good. I'm so glad. I'm so glad. Okay. All right. So that was out of 4 marks. So here again, statement reason. Statement reason. Okay. This statement together with that reason over there. Okay. So 4 marks on that. The last question is very difficult. Do you want me to go through it with you guys? I mean, again, it is the sort of thing that you would see in grade 11 and grade 12, or I've got some other easier questions. What would you prefer? Do you want to do the difficult question, or do you want to go and do some more easier questions? Whatever is the difficult one. Okay. All right. That's fine. The difficult one. Okay. Cool. Not a problem. Not a problem at all. Let's tackle the difficult one. Good. I like the enthusiasm. Wonderful stuff. Cool beans. Okay. You see, and as you get to understand this section a little bit more and more and more, it becomes easier and easier to see these things as time goes on. It's like with anything, the more you practice it, the easier it becomes. Okay, so they want us to prove that Fs is a tangent to the circle at S. So Fs is a tangent to the circle at S. So if we just go back, remember they did tell us in the beginning that line Fs is a tangent. Can you see it's touching the circle there at S, but we don't know that it is a tangent. Okay, so how could we prove that Fs is a tangent to the circle? What do you know? Like you were saying, like when I said, how do you prove that a quad is cyclic? You guys said to me, oh, the opposite angles must add up to 180. Or how do I prove a quad is cyclic? Oh, angles in the same segment must be equal. So I'm asking you, how do you show that a line is a tangent to a circle? Absolutely, Cassandra. So that would be one way of doing it. If there was a 90-degree corner here, absolutely, because O is a line that comes from the center. Quite right. So if we could show that this was a 90-degree corner, we could use converse, radius or diameter, perpendicular to tangent. Lovely. Well done. You guys do know this. Or, absolutely, Teddy, but it's the converse of that. Okay, if there was an angle, now Lebogang is saying, would it be angle Q? Where's Q? No, it wouldn't be Q to X. I'm not understanding you there, Lebogang. Cassandra is saying that FSO is 90 due to angles equal. Okay, so opposite angles of a cyclic quad are supplementary. You're on the right track here, Cassandra. Good. Okay. We've proved that the quad is cyclic. Cassandra, you're seriously onto something here. Okay. What do you know about the opposite angle? Everybody knows this. Remember they told us in the beginning that PQ is a tangent. We know that O is the center of the circle. So what can we say about OP and PQ? What can we say about OP and PQ, everybody? If PQ is a tangent, they gave us that in the beginning. What can we say about OP and PQ? Remember, OP is a radius. There we go, Lebogang. The tangent is perpendicular to the radius. Yes, Gugu, wonderful. Perfect, perfect, perfect. Okay, so now let's tie that together with Cassandra's suggestions. We've just proved that this pink quadrilateral is cyclic. We've got the angle at P equal to 90 because we've been told PQ is a tangent and we know that OP is a radius. We know that the opposite angles of a cyclic quad are supplementary. So the angle at S, FSO, also has to be 90 because we've proved the quad is cyclic. Okay, so because this angle over here at S is also 90, line FS has to be a tangent to the circle. That's really good. You guys put this together. It's not me giving you the answer. You guys have come together and done this. It's really good. Do you want me to say that another time? Yes, okay. All right. So let's look at the diagram again. Okay, no problem. All right, so everybody looking at the diagram. Remember they told us in the beginning that PQ was a tangent to the circle. So we've got PQ is a tangent. Can you see I'm underlining it in green for you guys here again? If PQ is a tangent to the circle and OP is a radius, then angle OPQ has to be 90 because of radius perpendicular to tangent. Okay. We've also just proved that POSF is cyclic. Opposite angles of a cyclic quad add up to 180. So the opposite angle at FSO or OSF also has to be 90. This has to be 90 here because the quad is cyclic. Okay, and because this angle over here, the one at S, because that's 90, FS is a tangent, converse, radius perpendicular to tangent. Okay, so let's put that down. And if you need me to say it one more time, then I can do that. I'm just trying to think where I can write this where we can see it at the same time. I don't want to squeeze it in here. Okay, so the first thing that we need to establish, what I'm going to do actually is I'm going to stick it over here so that you can look at the diagram while I'm writing it. Okay, the first thing that we wanted to say here in 9.3 is that OPF equals 90. Radius perpendicular to tangent, okay, because we're given that PQ is a tangent and OP is a radius. Okay, then we are going to say that angle FSO equals 90. Opposite angles of a cyclic quad are supplementary. Okay. Therefore, Fs is a tangent converse radius perpendicular to tangent. Okay, so OPF is 90, radius perpendicular to tangent. The radius being OP, the tangent being PQ, we're given that. We've now proved that the quad is cyclic, the pink quad is cyclic, so angle FSO equals 90 because opposite angles of a cyclic quad are supplementary. That proves that Fs is a tangent to the circle because of converse radius perpendicular to tangent. Okay, and we know that OS is also a radius. Okay, so we've proved Fs is a tangent to the circle. Okay, so when you want to prove that a line is a tangent, it can only be done in two ways. Either converse tan chord theorem or converse radius perpendicular to tangent. Okay, those are the only two ways. Lebogang, you're welcome to unmute and speak.
Ma'am, can I ask if they gave us a specific quadrilateral, would we have to use its its properties to prove certain questions? Like if they gave us
sorry, Lebogang,
like
yes.
pi or something.
Yes, absolutely.
Yes,
So
absolutely.
it becomes more important in grade 11 again, in grade 12 again than it is in grade 11, where you would have to use the properties or characteristics of parallelograms or a rhombus or some quadrilateral in order to prove stuff. Absolutely. But it doesn't come up as much in grade 11. So the grade 11s don't have to worry about it as much. But by the time you get to grade 12, yes, it's almost as though grade 12 is sort of the culmination of what you do in grade 10 with all the parallelograms and quadrilaterals and whatever, and then your grade 12, grade 11 circle geometry. So yes, they would expect you to know that. Okay. All right. So we've got a little bit of time left. Yeah, it would be Lebogang, it would be in your June exam. So definitely. Let's just have a look at where the marks would be allocated for this. Again, it was out of 4. So we would use statement, reason, mark. So it would be statement, reason, and then here it would be statement, reason, and then that would be a reason. Maybe there it would be statement, reason, and then there a reason mark. Okay, let's go and have a look, if everybody's cool with that, at just some of the other things that they asked us. We've got 20 minutes left. I could do this question with you, which again is a little bit easier. Or if you wanted, we could just try and have a look at something that was just sort of slightly more challenging. This is a very nice question. I think we should do this one. Are we happy with that? Yeah, just a slightly more difficult one. We won't tackle the very, very difficult one with so little time to go. Okay, cool. So again, reading the information that comes with the diagram, they've told us, look here now, guys. Now we've got 2 tangents. In the diagram, tangents PQ and PS touch the circle QRS at Q and S respectively. So now we have 2 tangents. So what do we think about straight away when we've got 2 tangents? A question like this was in the June exam. Ayanda, if only we'd done this before. I think you're in grade 11, Ayanda. Is that right? Yes, okay. Oh, goodness. Okay, so straight away, tangents from the same point. Now, tangents from the same point is important because if this line over here equals this line over here, Then we've got two angles that are equal, again, because of quite right pulling. PQ equals PS. So which angles are equal? That's it. Msomi, perfect. Okay, that's it. Well done. All right, Q1 is equal to X as well. And you can see here one of the questions was, name with reasons, let's just move that guy out the way, name with reasons 3 other angles equal to X. So there you go. You've already got, again, by reading the information and interpreting it correctly, you've got part of the answer for the first question. Then they've told us that T is a point on QR such that PT is parallel to SR. So I'll just highlight these lines in pink. They are parallel to each other. They're not equal. Okay, so just careful there. These lines are equal. The pink lines are just parallel. They are not equal. So again, the minute we see parallel lines, we start thinking corresponding cone interior alternate angles. Okay, then they've said let S1 be equal to X. So now, similar to a previous question, name with reasons 3 other angles each equal to X. All right, so we've already got one. What we would need to say about Q1 in order just to set it out in 100% the correct way is we would do this. We would say PQ equals PS. Tangents from the same point. Therefore, Q1 equals S1 equals X. Angles opposite equal sides. Okay. Lebogang, we can't say radii TP and TS because there's no center. Yes, we don't know. So T could be the center, but they didn't tell us that, so we can't assume that it is. Okay, 100%. So no assuming. Okay. So we've got one angle equal to X. All right, how many did we need, guys? We needed 3 more. Okay. Can anybody else find another angle that could be equal to X? P2. Why would P2 be equal to X pulling? Okay, Shumela, why does Q1 equal S2 and S3? Okay, but be careful there. Okay, remember your alternate angles are between parallel lines. Okay, so line PQ is not parallel to line SR. Line PQ is not parallel to line SR, Lumelo. Good. Avuye, well done. Okay, now, Iletu, do you know for certain that QTSP is cyclic? Okay, it hasn't got, so it's different. Remember, Iletu, in this question here, we had to prove that POSF was cyclic because there was no circle drawn through POSF. Different to, where was it? This question over here. Remember here, we didn't have to prove that PECD was cyclic because PECD had 4 points on the circle. When we answered question 8.2, they told us ABFE was cyclic before we answered the question. All right, so in this question here, we do not know that QTSP is cyclic. So we can't use angles in the same segment unless those 4 points are on a circle. Okay, so someone did say it. I saw it. Gugu, yes. Avuye, good. All right, tan chord theorem. Okay, so the angle between the tangent and the chord is equal to the angle in the alternate segment. So line PS is a tangent. QS is the chord, and the chord goes to the circle at R. Okay, so both Q1 and S1 can be used to say that R is equal to X because of tan chord theorem. Good. Okay, so we've got 2 angles so far. And now you guys are saying Q2. Q2, I don't know for what reason. I wouldn't say Q2. Again, this is a little bit obscure like the other one was, that was the exterior angle of the cyclic quad. Anyone got any other suggestions? It's not Q2. Oh, there we go, Hlumelo. Well done. Okay, so Hlumelo has pointed out that it is T1. And the reason for that, everybody, is because of corresponding angles. So look here. Okay, this is what Hlumelo's seen. We've got this line here that is our backbone, and there are our parallel lines. Do you see that? It's an upside down F with its arms pointing in this direction. Do the rest of you see it now? Okay. So T2 and R are not alternate angles. T2 and S3, Gugu. T2 and S3 are alternate angles, but we don't know what S2 is equal, what T2 is equal to. Okay, so these are the only ones in this case. All right, so let's put the others down. Okay, so we said that R was equal to X because of tan chord theorem. And the last one was T1 was equal to X because of corresponding angles. And that is because PT is parallel to SR. Okay. Okay. Ayanda, why can't we say Q1 equals T2? Okay. Ayanda, not a problem, because we don't know, Ayanda, that this quad is cyclic. Okay. I mean, it could be, but we don't know that it is, and we haven't proved it. We haven't proven it, and we haven't been given it. Okay. So I'm just going to draw this quad over here. We don't know that that's cyclic. Okay, it does not have 4 points on a circle. So if a quad does not have 4 points on a circle, you have to prove that it's cyclic before you can use anything to do with a cyclic quad. Okay, if a quad has a circle drawn through all 4 points, like it did here with PECD, you don't have to prove that it's cyclic because it is cyclic. Okay, it's got its 4 points on the circle. Okay, so if a quad does not have its 4 points on a circle, you either have to prove it before you use it or be given it. Okay. All right. So T2 equals S3 because of alternate angles. They are, but that doesn't help us with our answering our question. Okay, because we do not know at this point whether either T2 or T3 were equal to X. Okay, so we can only get Q1 from angles opposite equal sides. We can get R from tan chord theorem, and we can get T1 from corresponding angles. Okay, so statement, reason, statement, reason, statement, reason would be the order of the day here for all of these marks. Okay, let's do this last one, and then we can perhaps call it a day. Now they say if it is further given that PQTS is cyclic, show that S3 equals Q1. Okay, so in other words, if we know that Q1 is equal to X, they want us to prove that S3 also equals X. All right, so how can we get S3 equal to X? Remember, this quad is cyclic. They've told us now that the quad is cyclic. So that means that angle T2 would be equal to X because of angles in the same segment. And then we have got alternate angles over here that would give us X. Okay, and then S3 would be equal to Q1. Is everybody happy with that? So they've now told us the quad is cyclic. Cool beans. Okay, so let's just put that down. So in 8.2, they tell us the quad is cyclic. So that means T2 equals X because of angles in the same segment. Okay, therefore S3 equals X because of alternate angles. PT parallel to SR. Q1 equals X. Okay, proved above. Therefore, S3 equals Q1. Okay. All right, so 3 marks for that. It's showing that S3 is also equal to X. So probably statement, reason, statement, reason. Sorry, statement, reason. Okay. Are there any last questions that you want to ask before we say our goodbyes? No, we're all good. All right. So the only question that we haven't managed to work through, guys, is this one over here. Okay, you will be getting the answers to this. It will come through. This is obviously quite a bit more difficult. Gugu, the best strategy that I can give you, all right, is like I was saying at the very beginning, okay? Read the information at the start of a question carefully. The moment you see a word, try and relate that to a theorem. So when you see diameter, angle in a semicircle, tangent, tan chord theorem, tangents from the same point, radius perpendicular to tangent. Okay, put all that information onto the diagram first and then go and look at the questions. Okay. Remember, when you are writing that something is equal to something, there has to be a reason. Okay, and it's often like this. This equals this, reason. This equals this, reason. Then we have the therefore, that equals that. And then we've proved whatever we want when it comes to things that are proofs. Don't make assumptions. Don't assume that a point is at the center just because it looks like it is. Don't assume a line is a tangent just because it looks like it is. Don't assume that lines are parallel just because it looks like it is. Don't make up information. Work with what you've got. Okay, the answer is in there if you know your theorems.